Hey everyone, Reis here with Cranberry Alarm REEFSCAPE FRC. I'm here today, I'm going to be demonstrating our ramp intake prototype. We have here a human player station built from the field specs provided by First for the team built human feeder station. So for this intake, we basically have this currently set right now at a 10-degree slope, and this top point right here is set at 33 inches from carpet. On the human player station, this point right here, I believe was set at around 35 inches, 37 inches. And so from there, we want to give it a little bit of area to fly into our robot, and our goal is to vector it into a single place so that we can then index it and score it. So we're using also our surface right here is polycarbonate. So we'll be demonstrating multiple different surfaces and showing what angles work and what angles don't work. So this is pretty standard. You drive up all the way, you're all the way centered, you're perfectly centered, and this is kind of how it's looking. Then we'll kind of throw in some more. Let's say you're angled a little bit. That does it okay. Let's say we're off to the side. And you can see it slowed down there a little bit. So if you had your mechanism to pull it through the rest of the way. Now let's go ahead and see with the human player giving it some oomph. There it is. See that one more time? There it is. And let's go ahead and back up the robot just a little bit. The robot. Go ahead. Let's see a soft one. There you go. And then we're going to go ahead and angle it some more and see how that kind of looks. And then go ahead and drop it in horizontally. So in this case, it didn't make it its way through. In most cases, it probably won't make it through. There it goes. So this is also a 22-inch width intake. Ideally, you would like this to be the entire width of your robot. So let's go ahead and see. We're a little far off right now. We'll go ahead and give it just a little bit more. Give it a little bit of room. Let's go and try that. So even it made its way through. Go ahead and give it some oomph. There you go. So here we have another iteration of the prototype. We've instead changed the angle from 10 degrees now to 5 degrees. All the parameters are still the same on this one. Polycarb base, 22-inch wide, vectoring. Let's go and give it a shot. So just dropping it seems to have it doesn't have enough velocity to get through the vectoring. It gets slightly through it, so maybe you would be able to grab it from there. This is also a very janky prototype, but I think it gets the point across. Let's go and try it with some oomph. All right, let's go and try vectoring now. So it's definitely not coming through with enough the same velocity that it was coming through before with the 10 degrees. The thing is, it was getting snagged a few times there. I feel a little bit more comfortable with 10 degrees. All right, so let's go ahead and let's move the wood now. For this prototype, we now have the wood base, still with the same parameters of 22 inches wide and vectoring. And we still have the 33-inch height, but this time we're at 10 degrees now. Just gonna see it with a soft touch. See some velocity. One more time. So it seems to be coming through just as well as polycarbonate. So good, I can't even catch it. All right, and let's go see some vectoring. It seems to slide pretty well up against the wood. Polycarbonate and wood seem to be pretty comparable from these tests, at least in this configuration. And let's try backing up just a little bit. Go and throw it. So it looks like if you just get too far away, it won't be quite as reliable. So ultimately, it may be best to drop this ultimate height right here down a little bit just to give you more wiggle room for accepting the game pieces. So for this test, we have now moved the human player station up 1.5 inches. So this moves the total height of this edge right here down to 31.5. So let's go and give this a shot. And the reason for moving it down is we want to go ahead and give ourselves a little bit more wiggle room by moving the robot back. So let's say you can't get your robot all the way up against the wall due to defense or whatever else. Very nice. And this is also on a 10-degree slope with a plywood surface. Do you want to give us some? Very nice. Let's keep backing it up till it fails. So for this one, based on your robot constraints, ultimately it comes down to the farther you can bring this down, the farther you can accept the game piece from. Depending on your robot constraints, that may fit some people. Some people may need it really high up. For us, this is where we may end up at. That should about wrap up our testing of the passive ramped intake while vectoring the Coral game piece. Thank you guys for watching, and be sure to check out more videos on Fun Robotics Network for Cranberry Alarm REEFSCAPE FRC.